The purpose of this video is to work on solving logarithmic equations. If you have not watched any of my other videos on logarithms, I recommend going back and taking a look at those first, because we will be using some of the techniques we learned in past videos to apply them here to solve these equations. So, let's jump right in. Here we have the logarithmic equation log base 6 of 216 equals 3x. Now, the best way that we're going to have to solve this is to convert all of this back into an exponential form. I feel that that would be one of the easier ways to do it. We'll see a couple different approaches with the examples we do, but the first one is going to be using a conversion. So, if we remember from one of the past videos, I can rewrite log base 6 of 216 equaling 3x as 6 raised to the 3x power equals 216. Now I have exponential forms and I want to solve for x. Well, if I'm going to solve for x, I need both sides to have the same base. Right now this side has a base of 6 and this side has a base of 216. So if I'm going to solve for this exponent, I got to change one of these bases into the other. Easiest way to do that is to change 216 into a 6, because if we know our cubes, 6 to the third power is 216. So I can rewrite the problem as 6 to the 3x equals, and instead of 216, I'm going to say it's 6 to the third. Now I have the same base. I have a 6 here and a 6 there. So we take our exponents and set them equal to each other. 3x equals 3. And using a little bit of basic algebra, I'm going to divide by 3, and x ends up being 1. That is the answer to our problem. And it makes sense if I were to put it back into log form. Log base 6 of 216 is going to equal just 3. Alright, so our first method for solving these, take the log and rewrite it in exponential form. Now let's try another problem. Here we have log base 3 of 20 equaling log base 3 of a minus 1. And we can't use the approach from before because this isn't an exponent. We can't say that 3 raised to the log of a minus 1 equals 20. Well, we can, but we're not going to. What we can do is the fact that since this is log base 3 and this is log base 3, their answer portions should be equal to each other. So I'm going to have 20 equals a minus 1. Once again, after changing the form, it just takes a little bit of basic algebra. I'm going to add 1 to both sides, and a equals 21. And logic dictates, if you have log base 3 of 20, if I put 21 in here, 21 minus 1 is 20, well, this is also then going to become log base 3 of 20, and that has to be equal to itself. So there we go. Another quick solution, just using a little bit of logic and noticing that our bases, well, these aren't the bases, but the log with base 3 is equal to the log of base 3. Alright, let's try another. Alright, here we have log base 4 of the quantity 4x minus 20 equals 5. Like our first example, I would recommend rewriting this. Exponents can be easier to deal with, so I'm going to rewrite this in exponential form. So I'm going to have 4 raised to the 5th power equals 4x minus 20. Now, unlike the first example, I can't rewrite this to have it as a base of 4. But that's okay, because look at all that's over here. It's 4 raised to the 5th power. It's not 4 raised to some x power, it's raised to the 5th power. Which means if I evaluate this side, 4 to the 5th, I can then use it to solve this. And 4 to the 5th just so happens to be 1024 equals 4x minus 20. Then, basic algebra time again. Add 20 to both sides, we're going to have 1044 equaling 4x. And then to get x alone, we'll divide by 4. And we'll get our answer of x equaling 261. And there's our answer. Changing it into exponential form helped out a lot. And then we were able to do some basic algebra to get our final answer. We're going to try one more example. It's going to bring back some stuff that we've seen a long time ago. So let's get into it. So for our final example, we have here log base 6 of the quantity x squared minus 6x equals log base 6 of negative 8. Well, what we have here looks a little bit different because none of our examples thus far has dealt with a x squared. And we can't rewrite this as a quotient property because the minus in 6x is not with its own log base 6. So we can't do that. What we're going to have to do though is realize, oh, I have a log base 6 over here and a log base 6 over here. So whatever this side is, it has to equal that. So we can start by taking those pieces out and getting x squared minus 6x equals negative 8. Now it looks like a quadratic problem, and it actually is. So we're going to have to first set it equal to 0. So I'm going to add 8 to both sides, and that's going to give me x squared minus 6x plus 8 equals 0. And from here we have two options. We could use the quadratic formula, it's always an option, or we could try to factor it. And factoring using the diamond method actually works out a lot faster. So if I have my diamond over here, which is basically just an x, remember up top it's a times c, so that's going to be 1 times 8, so I'll put an 8 up top. And then b down below, which is negative 6. And on the sides, we have to come up with two numbers that multiply to give us 8, but add to give us negative 6. Now getting 8 is pretty easy. That should be 2 and 4. But 2 plus 4 gives me positive 6, which means these both must be negative. So negative 2 and negative 4 add to negative 6. So we factor this down to x minus 2 times x minus 4, and that's going to equal 0. Now, what's our answers? That's what we need to get. We need to know what our answers are. Well, since in any equation, if it's equal to 0, this piece either has to be 0 or this piece has to be 0. So let's start with the left one. X minus 2 equals 0, so x must equal 2. Same with the second piece. X minus 4 equals 0, so x must equal 4. And you're probably wondering, hey, we haven't had any examples so far where we could have two possible answers, and you're right. But since we have a quadratic and an x squared, we're going to get two possible answers, and they both work out. So I'm going to erase this work in the middle for a second, and we'll see how they work out. Okay, let's look at our piece right here, x squared minus 6x. If these two logs are going to be equal to each other, this side better equal a negative 8. So let's put in our first answer of 2. We get 2 squared minus 6, whoops, hit the wrong button. So 2 squared minus 6 times 2, that's going to be 4 minus 12, which equals negative 8. Exactly what we wanted for over here. So 2 works out as an answer. Now let's check with 4. So if I have 4 squared minus 6 times 4, I'm going to have 16 minus 24, which also just so happens to work out to be negative 8. So we have two possible solutions for x here, 2 and 4. And that is the solution to this problem. It's a long one, but hopefully you got a lot out of it. Good luck on your future logarithmic equation solving endeavors.